Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called One Louder by ABW. And here are the rules. Excuse me while I put my cough drop in. We have normal Sudoku rules apply, which means place the digits 1 to 9 in each row, column, and 3 by 3 box without repeating any digits. We have digits in killer cages, sum to the total shown in the top left corner. And digits may not repeat in killer cage. That rule set doesn't really matter because they're all in the same row, column, or box. But yeah. So for example, if this were say a 4, this would have to be a 6 here because these two digits must add up to 10, which is the digit in the top left corner of that cage. And that's an example of how killer cages work. Digits on the black tap track lines can be grouped into digits summing to 11. All digits on the line must be in one and only one group. That is, there are no gaps between groups, and groups do not overlap. And digits may repeat in a group if allowed by other rules. So, for each of these lines, you have to break them up into groups. And every cell on the line must be part of exactly one group. So this could be part of a group with, like, say, these 2 digits, or it could be part of a group with, like, say, these 5 digits. But they must sum up to 11 as part of a group. Okay. Interesting. So these are similar to, what were they? I think 10 lines? I think that's what they're called. Except that these sum up to 11. So it's one louder. I think it's a reference to This is Spinal Tap, which is a movie, which I have not seen very much. I think I only know the references to the bringing it to 11. But anyways, so every digit on a tap line is part of a group that sums to 11. Is part of exactly one group which sums up to 11 on that line. And it's grouped up by being in a consecutive set with that, or not consecutive set. They must be adjacent digits along the line, right? To add up to 11. And digits can repeat in a group if allowed by other rules. And then finally, we have digits separated by a white crop key dot differ by 1. And not all such dots are shown. So for example, if this were, say, a 6, this would have to be a 5 or a 7 to be consecutive with that. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. First things first. We know these digits in row 9 already add up to 41 because we have 10 plus 10 plus 11 plus 10. That means the last remaining digit is equal to 45 minus 41, which is 4. Okay. We know these add up to 21. These must be an odd digit. Again, you have 45 total. So 45 minus 21 is 24. 24, which is an even digit, minus an odd digit, or odd sum, must mean leave an odd sum, odd difference here. So that means this must be odd here, which forces this to be an even digit. So this is 2, 4, 6, or 8. Right? Even digit plus odd digit gives you an odd sum, which 11 is. And this is one odd and one even digit here, right, to be consecutive. So this must sum up to an odd sum here. Odd plus even is an even sum for this, which means this is an odd sum. Odd sum plus even sum gives you an odd total. Can this ever be 8? 8 plus 1. Okay, so this is at most 17 here. 17 plus 11. And 17 plus 11 is 30. There's 28. Plus 10 is 38. So this is at most 7 here. Since this is at most 7, that means this has to be at least... No, sorry. This is at least 7 here. Right? This is 38 at most. Again, because these are 21. This is 17 at most. So at most total, this is 38, which means this is at least 7. So this cannot be more than 4. So this is 2 or 4 here. And here we have 4 unique digits adding up to 11. The only possible combination is 1, 2, 3, and 5. Which eliminates 1, 2, 3, 5 in the rest of the row. This can't be 2. This is now 4. So this must add up to 7 here. So 7 plus 11 is 18, plus 10 is 28. 45 minus 28 is 17, which is the maximum 2 digits can be. So this must be an 8-9 pair. Remaining digits of row 7 have to be 6 through 9. That's with 1 through 4 to add up to 10. 4 has to be here. 4 has to be here. Where is 4 in row 8? Cannot be on this next to the white Kropke dot. Can't be here because of 4's in the boxes, so it must be here. And this is a 4-7 pair. This adds up to 7 here. Cannot be 4, so it's 1, 6, or it's 2, 5 here. There's no 3, 4. That means this combination must have a 3, and it must have... Well, we have 3 digits in this box, which are from 6 through 9. To add up to 10, you also have to have another digit from 6 through 9, right? Because 1, 9, 2, 8, 3, 7, or 4, 6. Cannot be 3 or 4. This is 1, 9, or 2, 8 here. So that means 6 and 7 have to be here, which means this can't be 6 or 7. This is 8 or 9 here, which makes this 1 or 2. Remaining digits in the 10 cages are 1, 9, 2, 8, 3, 7. You can't have 4, 6 because of the 4 in the row. So this is 1, 2, 3, 7, 8, 9. No 3, 7 here. We have a 1, 2, 8, 9 quadruplet in row 9, which eliminates 1, 2, 8, 9 in the rest of the row. This can't be 1, 2, 8, 9. It's 3, 7, which leaves this as a 5, 6 pair. So here... We cannot have both 1 and 2 here because that would eliminate all possibilities for this cage here. So this has to be a 1 or 2 here. This has to have a 5 here, which means this can't be 5 here. So this is 6, which makes this 5. This cannot be 2 and 5, adding up to 7 here. So this must be 1 and 6, which eliminates 1 and 6 in the rest of the row. This can't be 1 or 6. This must be 2, 3, and 5 to add up to 10. That eliminates 2, 8 in the rest of the box to add up to 10. So this 1, 9 pair eliminates with 9 in the rest of the box. So this is 6, 7, 8 as a triplet, which eliminates 6, 7, 8 in the rest of the row. This can't be 8. This is 9, and 1 add up to 10. 1 eliminates 1 here, so it's 6 and 1. 1 eliminates 1 here, so this must be 2. This cannot be a 1, 9 pair here. This 9 eliminates 9 here, so this is 8, which makes this 9, which eliminates 1, 9 here, so none of these are 2. This digit's consecutive with that, so it's either 2, 4, or 6. 6 and 4, 7 and 3, and 2 and 8 add up to 10. These digits add up to 8, and there's no 6 here, so this is either 1, 7 or 3, 5. This is odd no matter what, which is consecutive with an even digit, so it's 2, 4, 6, 8 here. Which means this is odd to add up to 11. So this must be 3, 5, 7, or 9 to add up to 11. To add up to 14 here, it's either 5, 9, or 6, 8. Well, say we had a 6, 8 pair here. That would eliminate 6 and 8 as a possibility here. So it would be 7, which would be consecutive with another digit, which would have to be 6 and 8. But we already have both 6 and 8s here. So this cannot be 6 and 8. It's 5 or 9 there, which eliminates 5 and 9 in the rest of the column and the rest of the box. So this is only consecutive with 6, 7, or 8 here. These 3 digits must add up to 11, and we can't have it going this way because one digit by itself can never add up to 11. We have 34 here. 45 minus 34 is exactly 11. So this is a set that adds up to 11, which means either we have 4 digits adding up to 11 here. You can't have 3 and 1 because one digit can never add up to 11. And if we try to have 4, it has to be 1, 2, 3, 5, and this can't be 1, 2, 3, or 5. So this must be 2 and 2 adding up to 11. Therefore, this is 3, 4, 5 adding up to 11. And this is either 2, 9, 3, 8, or 4, 7, or 5, 6 here. There cannot be a 1 here. So we have 1 guaranteed here with 2, 8, 3, 7, or 4, 6. So 4 cannot be here. 7 can't be here because one of these 2 digits is 7 to be consecutive without 5 or 9. Okay, how much does this add up to? 11 plus 11 plus 8 is 19. That's 30. So this adds up to 15 here. So we have 11 here, 15 here, and this must be 9. Oh, this 1 eliminates 1, 5 as a pair here. So this is 2, 4. That means to add up to 10, you cannot have 2, 8, or 4, 6. So it has to be 1, 9, or 3, 7. And 1 cannot be either of these digits, so that means 9 cannot be here. We have a 3, 7, 9 triplet in column 8, which eliminates 3, 7, 9 in the rest of the column. So that means, so we're what do we have? 2, 5, 6, and 8 remaining. This can't be 2. This has to be a 5, 6, 8 triplet here. Because we have 1, 9, and 3, 7 here. We have 2, 4 here. This has to be 5, 6, 8, which eliminates 5, 6, 8 in the rest of the row. So we cannot have 5, 6, or 8 here. So this must be 1 with 3 or 7. And this can't be 7 here. That leaves the rest of row 3 to be 2, 4, and 9. 9 cannot be here because of 9 in the column. So this cannot be 2 and 9. It cannot have 4 and 7. So this is 3, 5 with 6, 8. 6, 8 is only consecutive with 5 or 7. So 5 or 7 cannot be here. 1 has to be somewhere in these cages. 1 can't be in the cages adding up to 11, so 1 has to be here. So this is 1, this is 7. That means this can't be 1, 9. This becomes a 3, 7 pair. This has to be 1 and 9. This 3, 7 pair eliminates 3 and 7 in the rest of the row. This can't be 3. This is 5 and 6 adding up to 11. This 9 eliminates 9 here, so it's 5 and 9. That leaves this as a 3, 8 pair. And 3 cannot be here because of 3, 7 pair here, so this is 8. That's 3. To add up to 10, this cannot be 2 and 8. It must be 4 and 6 here. And this is 2 and 8. That eliminates 2 and 8 in the rest of row 1. This can't be 2. This is 4, which means this can't be 4. That's 2. This 3 eliminates 3 here. This 1 eliminates 1 here. This 8 eliminates 8 here, so this is 2, which makes this not 2, that's 8. 2 eliminates 2 here. So this cannot be 1 here, because 1's only consecutive with 2. So this has to be 5. If we try to have 5 and 4 here, this has to be part of a set that adds up to 11. You can only have 5, 4, and 2 here, but that doesn't work. So this can't be 5 and 4, it's 5 and 6. This can no longer be 2. 5 eliminates 5 here, so that's 3. This can't be 3 or 5, it's 1. 6 eliminates 6 here. And 6 here. Remaining digits in column 6. 2, 4, 5, and 8. Okay. Huh. Six eliminates 6 here. We have 5 or 8. Remaining digits in column 9 are 3, 7 with 5 or 8. Okay. 5 and 8 here eliminate 5 and 8 here, so that must be 6, which eliminates 6 here. Remaining digits in column 7 are 3, 4, 7, and 9. What can add up to 11 with 2? Remaining digits in column 4. We have 1, 4, 7, and 9. And 1 is guaranteed to be one of these digits. Okay. Can this ever be 3? Yeah, you could have 2, 3, 4, 2. Can you ever have 2, 7 here? And I think the answer to that is no. None of these can be... Oh, this is 5, not 6. Remaining digits in column 5, we can have 2, 3, 4, 7, 9. Okay. If it's have 2, 7 here, this is at least 3, and that would add up to 12 at least, which is not possible. So this can't be 7. But 2, 3, 4, and 2 work. Ah, but it doesn't really work. Say we did have 2, 3, 4, and 2. The problem is, then this would have to be a 9, and 9 does not... This already adds up to 11 as a set here, so it can't be part of that set. 9 and 6 don't add up to 11. So this must be 2 and 9 to add up to 11, which means 9 cannot appear in the rest of the column. We know one of these is a 4. So these are... let's mark them as groups. So this is a group... This is a group here. This is a group here. This is definitely a group, and this is a group. We don't know how this works here. If this were part of a group here, the problem is 5 and 8 would have to form a group, and that's 13. So this cannot be a group here. It must be a group that way. 6 and 8 can't form a group, so it must be 6 and 5. So we're going to mark that as a group there, which makes this 8. Therefore, these two digits must form a... Well, could be... Well, you can't have 3... You're guaranteed 4 here. 3, 4, and 4 would have to be a group, but that's 3 unique digits in the same box. So that doesn't work. So this has to be 2 unique digits, right? Because you have to have a 4 here. And 7, 4 already adds up to 11. 3, 4 would have to be with another 4. So that doesn't work. So this has to be 4 and 7. So this is a group. This has to be a group here. So this is 8 and 3. So we have group here, and then this must be a group here. No 7, so no... It has to be 5 and 6. So this 3 eliminates 3 here. This is 7, 3, which eliminates 3 here, so it's 7, 3. This has to be 5 and 6 here. So no 5, 6 here, no 5 here. This can't be 5. This can't be 5 or 6, so this can't be a 5, 6 pair. This can't be 3, so that can't be 8 there. Three... How do you form a set here? Three, 2, 4, 2 doesn't work. We're guaranteed a 1 here. So it has to be at least 3 digits here. So either 3 digits that way, 3 digits that way, 3 digits that way. Can it be 3 and 5 here? It can be 3 and 8, that adds up to 11. Can it be 3 and 5? I think the answer to that is no, right? So if it cannot be 3 and 5, if it's 3 and 5, you have to have 2 and 1 in that same box. Or 3 here, obviously 3 can't be there. So this cannot be 5. Where is 5 in column 6? It has to be here. So this is 5. 5 to add up to 11 can only be with 2, 4, and 2, 4. Or 6. It can't be 1, 5 because no 1 is available in that column and no 5 is available in that column anymore. So it must be 5 with 2, 4, 2, 4 or 5 with 2, 4, 2, 4. So we don't know which. So it cannot be 8. So we have a 2, 4, 2, 4 pair in column 6. So this must be 8 here. So this is going to be a pair adding up to 2. So if this is 2, 4, 2, 4, that means this is 7. This could be 1 or 9. If this is 2, 4, 2, 4, that forces this to be 9. And you'd have 9, 1, which is 10, but 10 with 7, which doesn't add up to 17. So it cannot be 5, 2, 4, 2, 4. It must be 5, 2, 4, 2, 4 this way. So this is a set here, which means this cannot be a set here. This adds up to 15 for all 3, so it must be just 2 digits here. So we're marking those 2, so this must be 2 and 9. And this must be 4. It cannot... Ooh. We have problems here, then. 4 eliminates 4 here. So this is 7. Which makes this 4 and 7 here. That can't be right. Oh, I see what it is. It has to be 2, 4, 2, 4 as this set. Yeah. So this can never be 8. This can never be 8 because of this 5 and 8 doesn't work. You can't have 5, 2, 4, 2, 4 for that to work. So this has to be 2, again, if this 2, 4, 2, 4, that's 9 with 1 or 4 or 7 here. 1 and 9 would have to add up to 11 with another 1, so that doesn't work. And then 4 and 9 already adds up to 13, which doesn't work. So it cannot be 5, 2, 4, 2, 4. Can't be 5, 2, 4, 2, 4. It has to be 5, 2, 4, 2, 4 as a mix here. If this were 2, this would have to be a 4, 9 pair, which doesn't work. So then this has to be 4, this is 2, this is 9, this is 2. So this works as a pair there. This cannot be 9 here. So this is 1 with 4 or 1 with 7 here. 1 with 4 would require 6 here. 1 with 7 would require a 3 here. So this must be 1 and 7 with 3. So no, this 1, 7 pair eliminates 1 and 7. So this must be a set here. 1, 7, 3 adds up to 11. 2, 4, 5 adds up to 11. 2, 9 adds up to 11. 5, 6 adds up to 11. 3, 8 adds up to 11. This 1, 7 pair eliminates 1 and 7 in the rest of the column. So this is 4. That's 7. This can't be 2 or 7 or 3 here. No, 2, 3, 7 here. This 8 eliminates 8 here. So this is 2, which makes this 8. This 2 eliminates 2 here. So this can't be 2 and 8 here. This 8 eliminates 8 here. So this is 7, which is only consecutive with 6 or 8. 9 eliminates 9 here. So this is 4, which makes this 9. 4 eliminates 4 here. So it's 3, which makes this 7. Therefore, that leaves this as 5 and 6 to add up to 11. There's 6 eliminates 6 here, so it's 8. This can't be 5 here. So we have a 2, 3, 2, 3 pair in row 8, which eliminates 2 and 3 in the rest of the row. So this is 5. This cannot be 3, 8, or 4, 7 because of the 3 and 7 in the box. So this must be a 2, 9 pair, which eliminates 2 and 9 in the rest of the column. This 9 eliminates 9 here, so it's 2, which eliminates 2 here, so it's 9. 2 eliminates 2 here, so it's 3, which makes that 2. 2 also eliminates 2 here, so it's 8, which makes this 2. 6 here eliminates 6 here, so it's 4 and 6. This 9 eliminates 9 here, so it's 1 and 9. This can't be 1 or 3, so that makes this 7. This can't be 3 or 7, so that makes that 1, which makes this 3. Remaining digits in column 4 are 4 and 8. 8 can't be here because of 8 in the row, so this must be 4. That's 8. That leaves 1 and 6 remaining in column 3. 6 can't be here because of 6 in the row, so this is 1. That's 6. 1 eliminates 1 here, so it's 7 and 1. 7 eliminates 7 here, so it's 4 and 7. How much more solved could this puzzle be? The answer is none. None more solved. I don't know what that's a reference to. Probably this is Spinal Tap somewhere. But these are the parts that add up to 11. 1, 3, 7 add up to 11. 2, 9 add up to 11. 5, 6 add up to 11. 5, 6 add up to 11. 1, 3, 7 add up to 11. 2, 9. 2, 4, 5. 3, 8. 2, 9. 4, 7. 5, 6. 8, 3. And 5, 6. All add up to 11. And that's a solve. I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.